So I was telling you that in the response to the general dynamic loading and their transient response, that the general dynamic loading can be anyone which is basically going in different direction or whatever. So we can solve for very small time step and integrate, superimpose the small integration problem integral over a single problem by giving a range, and that superimposed problem that involve the evaluation of a multiple integral is called as the convolution integrals after the research by Duhamel. So it's called as the Duhamel integral also. So basically, what was the process that we take it? We know that if I say that at time t there was a certain load, then very small increment is made t plus epsilon. So overall, I can represent this change. This change can be represented in this triangular rectangular form, and I can take the integration of this step. Force is applied for this small time, and I can take the integration, and this impulse force is basically, you know, that this is a very impulse force which is acting for a very small time, and force into time will give us the impulse force, and why when we integrate it, it will be the total impulse force. So impulse force basically centered at t0 and having an impulse equal to the I is represented by I delta, the small impulse change. So, and we can solve the impulse which is changing in the time t minus tau. Let's say this time is t tau at this is the initial time t0, and this is the at the time t is equal to tau. So we also know that the velocity can, in terms of impulse, is I over m, and then the displacement can also be it will be initial velocity problem for undamped system, and we can solve it by unit impulse force. Let's say for the unit impulse force, uh, mm, this is represented by ht. For unit impulse force, this can be displacement can be represented by ht. It is denoted by ht, and it is written by 1 over 1 unit impulse. So I will be 1 over m omega sine omega t. And for damped system, we have to include the damping expressions. So either for the undamped system and for damped system, this is the response of the system. And when you want to solve for general dynamic loadings, same thing, that at time tau there is a certain things, then you take the increment d tau and put the same thing in the same equation in place of the impulse. You can put down the value of the p. So here the p into t time into m omega into sine of omega t minus 2, and then solve it. So after solving and further simplifying it, it becomes the Duhamel integral. So finally, it can be said that it is possible to solve the system by Duhamel integral and by taking the convolution integral and then by superimposing that, and or in other way, it is a kind of a Fourier transform. Fourier transformation से भी इसको हम solve कर सकते हैं. So this is the response to the general dynamic loading. Now the point is that how you can solve it. I mean this equation that is formed in terms of this convolution integral. So we can solve the different times. For example, if this is a P naught is applied on a structure, this is a simple case. Constant load is acting on the system. So this is a general equation. Now this is the response of the system. This will be the U. In this case, the U will be the equal to the displacement responses P naught over K, static response at start and throughout the system. This is the response time transient response. So for zero initial condition, we determine the condition A and B constant, and then we derive and you can put down the values, and this become the final response of the system. So when the system is subjected to the linear load which is constant P naught, this is the response of the system. So this is encircled. I have encircled all the important formula in all the handouts. So this is the response of the system for the step function. And when you plot this on MATLAB, and you see that if you plot this response, take the uh, P naught on that side. So U over P naught over K is plotted against the time over a time period, and you get this kind of response for different damping. So load was straight, but due to the damping effect, the response due to the different damping values is accordingly changing. So more is the damping, you see that the less vibration is there. Now you see the next, this is also the same thing. I mean the display, if you plot the displacement as a damping ratio for step function. So here further evaluations are carried out that if you compute this value, then what will be the response of the system. So as the damping is increasing, you see the displacement is decreasing. Now next is the linear function. This is called as the ramp. ये रैम्प फंक्शन इसको कहेंगे. रैम्प फंक्शन का क्या रिस्पॉन्स है? तो ये इसका जो फंक्शन बनेगा P फॉर दिस केस इज P नॉट T ओवर T. इक्वेशंस आपने पढ़ी होंगी कि लाइन की क्या इक्वेशन होती है. तो इस केस में अगर कोई कहे कि आपका T जनरल इक्वेशन आपने बनानी है, इफ यू वांट टू मेक द जनरल इक्वेशन, सो PT विल बी P नॉट T ओवर TT, and then you can put in place of force, you put this value, and then convolution integral or the Helmholtz integral is solved to find out the response and further simplifying it. And this is the response of the system when ramp function is added. And there are the two, this is one is TT over T when it was 2, then this is the curve is obtained when it was 1, then the straight line was obtained. So T basically T1 over T play a dominant role, that what is the ratio of these time. So this is the T1 where this ramp function is ending. We have to mention that important points that what are needed for evaluating the response. Now another response of a system when a structure is subjected initially from 0 to T1 with the increasing ramp function, and when T1 onward it decreasing ramp function. So in the first part the function is this one, in the second part the function is this one. माइनस हो जाएगा ना, डिक्रीमेंट हो रहा है. और t माइनस T1 क्योंकि T1 से आगे है तो t माइनस T1, t जो है वो जनरल है एट एनी टाइम, T1 स्पेसिफिक है एट, ये नॉन वैल्यू होगी T1. P नॉट आपको नॉन होना चाहिए, T1 नॉन होना चाहिए, फिर आप इस फंक्शन को इवेल्युएट कर सकते हैं. तो लोड की वैल्यू और जिस टाइम पे वो चेंज हो रहा है और इसका फंक्शन हमने फिर खुद ही आपने सारे ये फंक्शन पढ़ने हैं, that what kind of function is representing the wind loading, what kind of function is representing the ramp loading, linear function. तो ये इसका जो है वो U1, this is the response of the system when the ramp function is first part में, और second part में जो response आएगा that is the second part. इनको sum करेंगे, the total response will be the sum of the first part when time is less than T1, और जब टाइम ज़्यादा हुआ T1 से तो फिर ये response आ गया. तो sum जो है वो इसका हमने, तो इसी बेस पर अब रेस्पॉन्स स्पेक्ट्रा बनेगा. हमारा रेस्पॉन्स जो है ना वो हम बिल्डिंग, हम डिफरेंट टाइम पीरियड हिस्ट्रीज उठा के तो बिल्डिंग के लिए जो है वो हम एक पीक रेस्पॉन्स प्लॉट करेंगे, एंड देन वी विल अप्लाई. दिस टॉपिक इज आवर नेक्स्ट टॉपिक, सो आई एम नॉट डिस्कसिंग इन डिटेल. सो दिस इज द रेस्पॉन्स स्पेक्ट्रा, आवर नेक्स्ट टॉपिक. अब आ जाता है इसका एग्जांपल है इसकी, एक लोड विच वाज अ सडन अप्लाइड लोड, इसकी इक्वेशन भी दे दी गई है. द इक्वेशन ऑफ दिस लोड इज P नॉट. अब ये P नॉट एक्सपोनेंशियली रिड्यूस कर रहा है, मतलब ऐसे नहीं डिक्रीज कर रहा, कर्वेचर इसका रिवर्स है. इसका मतलब है कि e रेज टू पावर माइनस AT, इट इज डिक्रीजिंग विद द e रेज टू पावर. P नॉट इज द इनिशियल वैल्यू. अब टाइम के साथ decrement is happening with time, so this can be represented as this is a function. अब इस function में no damping, ignoring the damping effect, this will be the equation. This is the load, this is the K and mass, और इसके ut जो है आपका जो Helmholtz integral, you put down the values of that function P naught bar ले आए m omega and solve it further, and then this one. So this is the applied loading and this is the response of the system. This U is plotted, U naught over P naught K is plotted as a function of the time, and you see what happening. that the displacement is increasing on the negative side as the load is increasing, although displacement is decreasing, but at the same time increasing in the negative side. So keep the vibration keeps on, and finally maybe at some instant the vibration will become minimum and like it will become to zero, but it's like that. So it says you should plot this diagram in the MATLAB. In the MATLAB E के लिए जो है वो आप exp यूज करते हैं कमांड एक्सपोनेंट के लिए, you can write it as exp. इसी तरह एक और प्रॉब्लम है ब्लास्ट इंड्यूस्ड प्रेशर का, that when the blast is acting on some building, initially जो है वो जीरो है लोड बिल्डिंग पे, सडन ब्लास्ट is एक जो है वो इम्पैक्ट लोड आपको पता है कि व्हेन एवर द ब्लास्ट हैपन्स इट एक्ट एट द फ्रंट फसाद ऑफ द बिल्डिंग. तो ये फ्रंट जो है ये दिस इज लेट्स से दिस इज अ फसाद ऑफ द बिल्डिंग एंड ब्लास्ट लोड occurs एंड इट्स वैल्यू इज इन द इन टर्म्स ऑफ प्रेशर है. हमने पीएसएफ में हम एक प्रेशर अप्लाई करें, सडन प्रेशर अप्लाई करें, तो इसमें प्रेशर है लेकिन फिर वो सडन डिके होता है और उसकी इक्वेशन जो डिक्रीमेंट किया वो 100 ई रेज टू पावर 80 माइनस ई रेज टू पावर गिवन होती है. ये हमें यानी कि देखना पड़ता है कि हम इस पर कौन सी इक्वेशन लगाएं. मैथमेटिशियन कैन हेल्प अस इन अंडरस्टैंडिंग दीज थिंग्स. एंड 100 इज द मैग्नीट्यूड एंड ई रेज टू पावर माइनस 10t माइनस ई रेज टू पावर माइनस 100t, यानी कि इसका डबल फंक्शन आ गया इसका, बिकॉज इट्स इंक्रीजिंग फर्स्ट then it is decreasing. So you can make this curve by putting the different values of the time. अगर आप put करेंगे ना तो you will get the same curve by putting the changing the value of the t. And now the exposed area of this building is 144. The area used will be the same which you using for the wind loading. That's why they are writing that. But blast loading, if you want to compute the effect only on the top level, तो इसमें half आप लेंगे because half of the effect will go to the base and half of the effect will go to the floor level. So we are investigating the floor response. Floor का response लेना है तो area will be half. So this is the omega. This is the total force area force is equal to A by 2 because half area into pressure. ये pressure की value given है, pressure is given. So you put the values and you get the results for the blast induced pressure. Now this is the force. Now you apply in the Hamel integral the force multiplied by the dt, the time increment, and this is the force function, and then you can solve the response. Just the t जो है वो variable रह जाता है. Now you take the MATLAB file and take the variable t जो है वो कोई भी आप ले लें 0 to 10 second and take the u on the other side. This value equation is there and you can plot the. This is the response of the system against the blast loading. In this way there are many other functions in this chapter which include the shock impulse loading, इसको कहते हैं, that there is a constant load, sudden it decreases minus में चला जाए. So this is a shock impulse load where a load is like going like this and this. So you can also have this kind of loading. So again up till T1 the performance is different, after the T1 the performance is different, and you can plot the response of the system. In this case the response will be very different and you can ये इसका relation है T1 over T और plot P का. ये response नहीं है, ये displacement ratio है, ये displacement ratio P naught के साथ. इसका response ये है. This is the response of the shock impulse loading. ये भी ratio है वैसे, ये this is the response. Static displacement, हाँ ये response ही है. All are the response ut divided by the static and with respect to the time. हम divide कर रहे हैं u को ना p naught over k से. That what is the effect कि अगर if there is a ये static response है p naught over k and j जो है वो time varying response है. So we are dividing it with the single magnitude values. Actually this comes on the left side in all the equations. Now the response is depending upon the TD over T and natural time period and the damped time period. इस case में जो है ना response उस पर depend कर रहा है. You see that when it is increasing you have the different response. So that's why the damping depends upon the damping ratio. So damping जितनी जो है वो change हो रही है, आप देख रहे हैं कि damping वगैरह बढ़ाने से उसका response जो है वो vibration is reducing, and it's kind of a sudden failure, and basically you have studied in that over damped system की तरफ चला जाता है, and when it is a normal under damped structure it keep on certain vibrations and then it becomes zero. तो ये इसी तरह ट्रायंगुलर पल्स है, अगर इसकी पल्स हो T1/2 तक डिफरेंट है, फिर T1 तक है, तो द रिस्पांस अप टिल द T1/2, द रिस्पांस अप टिल T1. तो ये डायरेक्ट इक्वेशन लिखी गई है, नो नीड टू प्रूव गेट द प्रूफ ऑफ दिस, बट यू जस्ट नो द फाइनल इक्वेशन फॉर दिस केस सो दैट यू कैन अंडरस्टैंड कि क्या रिस्पांस है. ट्रायंगुलर अगर पल्स होगी किसी भी सिस्टम पर, ये प्रॉब्लम आप सॉल्व कर सकते हैं, पुटिंग डाउन द डिफरेंट वैल्यूज ले लें P0, T1 की, T की, and then when you plot the response you will get this kind of response. It is interesting that the load is a triangular but the response is totally different. So in this way the structures are and the damped systems are behaving actually. और इसी तरह sinusoidal है, like we have studied today the response of the sinusoidal wave on a building. तो इसका अगर आप वैसे अगर इक्वेशन में लिखना चाहें तो it will be up till the T1 the response is this one, after the T1 the response is this one. So this is a sinusoidal response of the structure. ये finally response है, diagram of the displacement versus time ratio. ये एक और प्रॉब्लम है ग्राउंड मोशन के रिलेटेड, कि अगर आपने लोड नहीं शो कर रहे, हम ग्राउंड वेलोसिटी बता दें, यानी कि एक स्ट्रक्चर है, एक सिस्टम है सिंगल डिग्री ऑफ फ्रीडम एंड इट इज सब्जेक्टेड टू द V0, सडन इधर आपने कोई वेलोसिटी इंसर्ट की, व्हाट हैपन टू द रिस्पांस ऑफ दिस सिस्टम एट द टॉप नोड, क्या होगा. तो यू नो कि इसका फंक्शन दिया जाए, इस वेलोसिटी का क्या फंक्शन बनेगा, जो V0 है एंड एंडिंग एट T1, इट फंक्शन इज V0 into 1 - T/T1, और इसका डेरिवेट करेंगे तो एक्सेलरेशन आ जाएगा. नाउ यू हैव द वैल्यूज mu और ku, ये किसके बराबर होगा, द गवर्निंग इक्वेशन ऑफ द मोशन इज mV0/T1. तो यहाँ से आप जो है वो इसको सिंप्लीफाई करें कि u0 इनिशियली इज 0, displacement and velocity it is given initially which is equal to the total velocity minus the ground velocity, वो जो है वो V0 के बराबर है. And the response of this system when it is subjected to the velocity when time is less than T1, then it is this response, and when time was greater than T1 beyond that point, इससे आगे जो है the response is equal to this one. तो ये इसकी equations हैं which are not encircled, but these are the equation for the system which is subjected to the velocity. जब उसकी वेलोसिटी के आप सब्जेक्ट कर रहे हैं, तो ये अगर इसका लोड है एंड व्हेन यू प्लॉट इट यू सी अनदर दिस काइंड ऑफ रिस्पांस, ये जो है वो ये रिस्पांस है सिस्टम. दिस वाज अबाउट द बेसिकली रिस्पांस ऑफ द सिस्टम टू द जनरल डायनामिक लोडिंग. सो इट वाज इंटरेस्टिंग चैप्टर बिकॉज यू सी you learn the response of the different systems subjected to the any loading. And why we studied this chapter, why I gave you idea, because I want that you should understand कि अब जब आप स्ट्रक्चर पे रिस्पांस रियल पे रिस्पांस लगाएंगे, आई वांट दैट यू गाइस शुड बी एबल कि अब आप बेस्ड ऑन दिस रिस्पांस, नाउ इफ you apply the response earthquake response on the structure which is very haphazard, then what happened, how you can solve this time history and the response spectral response to the structures. This was the target for getting this. So try to work on this chapter also and study the different aspects. If you have any question, then you can ask. Any question from your side? Yes.
नो सर, कोई क्वेश्चन नहीं है.
You are tired? रोजे लगे हुए लगते हैं आप.
नहीं नहीं सर, ऐसी कोई बात नहीं।
Okay. So you have started working on these some dynamic, कुछ किया आपने, चैप्टर्स वगैरह पढ़ लिए?